record. Um, Videos are going to be posted, so you all have this at least. All right, we are going to talk about decomposition today. And then that is going to be pretty much it for OOP, D, and A. Starting on Wednesday, we will be going over test-driven development. So start thinking about unit testing your stuff. I warned you very early on that we would be doing that. That's going to be the next thing that we talk about. So with that, let's move on. All right. So decomposition. Does anybody know what this is? That is live on stream right now. Other than a ton of images that are watermarked and trademarked in in Google. That's a zombie. That is a zombie. All right, there we go. Any guesses on... So decomposing means to basically break apart, right? Well, I suppose decomposition for us is taking some kind of a problem and breaking it apart into smaller and smaller pieces. So, lovely zombie joke here, breaking apart into smaller and smaller pieces. Obviously a very cute one. Could be a little bit nefarious, depending. It's got that evil eye look to it. But for us, sometimes we have problems that we can't solve. So there is always going to be a good chance that you are going to run into a problem when you start designing projects where you can't just apply a design pattern to fix everything. You may have the case where, maybe you don't understand a requirement. Maybe a function that you want to implement is a little bit tricky, and you don't really know how to incorporate it or how to flesh it out. There is not a pattern, there is not an anti-pattern. There is some kind of a stopping point where you really need to analyze things. And this can be at any level of the software engineering process. It could be when you're coding, it could be when you're analyzing the whole environment, the whole problem domain. It could be when you are creating your UML models, right? You may have something where you just need to sit and think about it a little bit more. And the engineer in all of you will break that into manageable chunks, right? Little manageable pieces that you can work on. So what are we doing here? We are isolating key problems and we are trying to figure out a solution to them. Again, it can be at any level. We're going to talk about each of these today. For decomposition, we're going to start at the bottom and kind of work our way through these in seemingly a jumbled order. But basically, you can look at different key pieces of the overall engineering process, right? We could look at it in an object-oriented fashion. We could look at events. We can look at functions. We can look at data. Effectively, you have so many pieces that you can work on that you're never going to run out of things to do. But you should be able to realize, and hopefully, a lot of this to me when I say it, it sounds like common sense. But if you don't understand something or you're struggling, break it down into manageable pieces and work on those, and then feed that back into the overall design. So let's see where we are at. Slide 3. Good. All right, so first and foremost, let's talk about object-oriented decomposition. This is the high level, right? So we have been talking about object-oriented everything in terms of, the last couple lectures. We've been looking at analysis, again, whole system, design, take that system model, iterate it into near implementable pieces, and take that into OP and actually start implementing it. Here, we can look at it at different levels of basically abstraction. High level, low level, just depends on where you want to look at things. Basically here, let's say that we have some notion of a module, right? We are implementing something, or we are designing something. If we need to really figure out how this object, and again, another hand-wavy kind of day, how this object features into the system, or sorry, how this module features into the system, we can try plugging our objects into it. What makes sense to connect? figure out what the types of objects are that we need. Do we need a struct? Do we need a specific class that implements some feature? Does it have to be decomposed and generalized? Right? How are they going to incorporate in the system? So that'd be your high-level design. How are things related to each other? You could get into the low-level design. What are its attributes? What are its operations? Think of all of these UML models that we've been working on, and I've just been kind of giving them to you piecemeal, right? But if you're sitting down to design your project from scratch, or you're working together on a team, you start adding on, okay, we need this particular object in our system. Well, what is it going to do? Take one of your games, for example. You need an enemy in this game, right? Okay, well, enemies are cool. How do we do it? Well, enemies need to move around. They need to fire. They need to have hitboxes. They need this. They need this. They need this. We are decomposing this enemy class into manageable objects, right? And then look at it from a higher level. How does it fit in with the rest of the system? Sorry, 1 second. Is he in here? Okay. Okay, bye. Guess I should be doing this. My 1-year-old is sleeping today. All right, so the other aspect is the relationship. This enemy class, how does it fit in with your greater system, right? Is it a top-level entity like your player class? Is it part of the environment? How does it relate to everything else in your system? So object-oriented decomposition, look at things at a high level, at an object level. What are its attributes? What are its relationships? And here we have an example of decomposing a system. This is kind of bastardized class diagram in a way. Basically, we just have the top level kind of class idea and maybe what its interactions with other objects are. So here we are basically doing a file read and write. So some of the things happening behind the scenes in your operating system. Different example, so I don't always talk about games. But let's say that we have some file and we need to update it. All right, well, this file gets an update statement coming in. It's possible that we are going to treat this like a record set type of file. Maybe it's a CSV. Maybe it's a local database instance or something like that. But we have some methods that we can attach to this file. Now, if we want to update something in the file, we need to then update a record. Well, a record's going to have a get, a put, create, maybe some other functions as well. They would be tied to that. What does the record have? Well, if the record is going to be if we're going to make a valid update, we may need to check its checksum value. So calculate, did this update stick? Is it correctly implemented? Things of that nature. Sanity check for inserting data, basically. So the point here is not necessary to go through exactly how we do updates to files and all that, but here we are decomposing this process into manageable pieces. And if you look at this, it's basically a very high-level class diagram with the relationships attached to it here, right? So here we're just decomposing things. All these activities I've been having you do as homework or in classwork, this is effectively decomposition. And here we're doing it at the object-oriented level, so quite high up there. That makes sense so far? So the next step then, let's look at it from the functional perspective. So first, object-oriented. If you get lost in what all these different types of decomposition are, look at the bolded word. Object-oriented, looking at the objects. Functional decomposition, we're looking at the functions. So take your functions, break them into modules. So let's say that we have a requirement specification and we have a list of functions that we have to implement. Right, so let's go back here. Here are some functions: update, get, put, create, match, is valid add. Let's consider this one function. Effectively, how do we take these and decompose at this level? Well, it's possible that we can basically group them into modules, so almost going a bottom-up type approach here where you have some functional description and we need to figure out how they're put together. Or you may have a very complicated function and you think this is a little bit too complicated. Let's break it up into sub-functions. Right, so consider your All right, go back to the game example. You have a forever loop, right, that's running your game. This is in your main function. Then you are updating all your enemy states. Then you update your player state. Then you update the graphics. Then you do this, then you do this, then you do this. And it's all in one while loop. Well, this is way too complicated. Break it up into functions. Enemies.update, player.update. We're decomposing a very tricky function into a bunch of sub-functions. So breaking things up and, again, decomposing, getting a little bit more, you're almost getting into more of a cohesive type of thing here from last time, right? So let's try to really partition things out here. Now, if you are struggling to understand this part, maybe consider, instead of a game, consider an embedded system, right? So something where you don't necessarily have as many object-oriented features. Everything is going to be procedural. So you have just a list of functions that you call. You don't have some kind of a nice big object-oriented setup like this. You have maybe something more inline, more procedural, more in order. Another way to consider this type of decomposition. Let's see. So I thought I skipped something. So here is another example, honestly, of breaking things into functions. So here is a hotel system, right? So you get your requirement spec, create a system for managing your hotel. We could break this apart at the object-oriented level, but we're going to look at it from a functional level here. What are the functions that we have to do? Well, when a person logs into our system, we have to make a call to reserve room, to manage services, to check in your work time, reserve services. Here's some high-level functions that we have to perform. Again, maybe we got this out of a requirement spec. Maybe it was a user story. You got a directive from on high, who knows. Point is, these functions need to be there for your other developers to call. Okay, well, I don't know how to implement this. Let's break it apart into pieces. What do you have to do to reserve a room? You have to log on. Okay, makes sense. You have to check if there's anything available. See if there are any promotions available to the user. And then record the reservation. Consider these all as functions or methods that you can call, and then you can hopefully see how we're decomposing things into manageable chunks. Now again, I could make reserve rooms one massive function, or I could break it up into pieces. It goes to that notion of reuse and maintainability, and ideally, life is good. So, functional level, object-oriented level, different levels of abstraction. Hopefully that makes sense. Another kind we have is feature-oriented. And I will warn you, this looks very similar to functional, but the notion here is different. So here, instead of looking at functions, and again, I'm considering functions like something that you would call like an operation or a method or an operation. Let's take some feature that we know we have to implement and assign it to a module. Now this could be, again, high level, we're going to have a collection of features. Low level, how do they interact? What are the relationships? How does it support some pre-existing module or service? Basically take some nebulous idea of a thing that has to be created, and again, decompose it, break it into parts. So here I've got a feature diagram for you, and it probably looks very similar to that functional diagram from before. The key here, though, is that we're talking about features and basically like services or pre-existing modules. So, I'm trying to figure out what this one was supposed to be. It almost seems like it's some kind of a graphical application in a way. So, volume, patterns, transitions. I grabbed this one off of Google Images and I realized I didn't actually look in to see what it's describing here. Like video edit. Yeah, it kind of looks like video editing, doesn't it? But you have array patterns, you have transitions, maybe you're trying to do some kind of... I mean, to me, this almost looks like something that you would do in MATLAB or something like that when you're filtering images or videos or something of that nature. But yeah, so let's say that we have a feature. We need to add or subtract volume from it, so we could be bulking up some object or removing mass. Maybe it's a 3D image or something of that nature here. I think this, the more I look at this, the more I think it's like morphing objects, whether it's 1 or 2 or 3D. Like how do you make them smooth between edges and things of that nature? Anyway, um, so here are some features that we have to implement. And again, volume transition pattern, maybe we don't have specifics on what the functions are for this. We just know that this is going to be some feature that you have. So if this is video editing or Photoshop or something of this nature, we could be adding in different filters. We could be adding in different transitions. We could be adding in a whole bunch of things that the user can select. Well, what is a filter in Photoshop or Premiere or, something open source, but a collection of modules, right? So they're basically just photo filters that you run images through and you get an output. So you can almost consider that to be a high-level feature, break it into little sub-features or modules, and break it down even further. And then again, you get nice manageable chunks. So here, again, this looks very similar to functional decomposition. We even have a very similar diagram type here, right? So here is functional, this is feature-based. We are breaking things apart, but features are almost like collections of functions or more directly relatable to modules, right? So they're pieces of a feature, effectively. And the point, again, let's break things down. Let's try and get it to be in a manageable state. This could be driven by any of your software artifacts, requirements, user stories, design documents, anything that you've done so far. You could come up with a feature for, and then you could probably break it down. Right, so those of you doing a calculator app, your high level is you're doing a calculator application, right? I need a graphing feature. I need a calculus feature. I need a trigonometry feature, which I don't think you're working on, if I remember right, but you can kind of see how you could break this down into features or basically modules. You don't have specific functions that you're implementing here yet. That would come further and further and further down this chain of decomposition. All right, so we've got 3 so far. We also have data-oriented. So it is possible that you are going to have a data-driven application. It's kind of a buzzword right now in industry anyway, right? Everything's got to be data-driven. So how do we decompose in this manner? Well, we understand that there are modules that exist. They will be consuming data. They will be formatting data, manipulating data, and then outputting data, maybe even storing data. How is data going to flow across your application, and what are you going to do with it? This is also a very important point to understand from your perspective as project managers, software engineers, developers, whatever you're going to become. But here, if we're decomposing from a data-driven perspective, how are you storing data? How is data coming in? How is it going out? What transformations will be applied to your data as you go? Basically here, think about your program and what you're doing with all of this data that you have. So I like the video editing example here because it's different than everything I've been talking about. Your data coming in is a video, right? So you're going to manipulate this video. Maybe you're going to add some effects, maybe turn it into an HDR video, chop it up into manageable pieces so you have chapters for like a DVD or a Blu-ray or something like that. Whatever you're doing. I guess some of you are probably YouTube video editors, so you got to get all those nice jump cuts in there to make things pop. But your data coming in and going out is this video stream, which is just a series of images, really. So you probably are going to store it in some format. How are you going to break it up into pieces? What is this data format going to be? At a high level, maybe it's just an array list of videos or video clips or something like that. Maybe you have a list of filters that are being applied at a particular time. Well, how do you represent that? I need a class or a structure saying filter ID, duration, start time, end time, something like that. But here, at this level, you kind of start to see how you're handling data. And this can be different than your feature model. It can be different than your object-oriented model. Here we only care about data. Now, can you link these all together? Sure, why not? I mean, it might make sense that this module has all of this data attached to it. Here's the data coming in, here's the data going out. But if we look at it from a diagram perspective, and I should probably specify that a lot of these models that I'm showing you, I'm not putting any formal rigor behind them, meaning that the actual graph representation or the model representation that I'm showing you, none of these are strictly formal like UML. It's more for descriptive purposes. Ideally, you'd put like a little legend on here saying what each object is so other people know how to read this thing. But here's one perspective of a data-oriented decomposition. So here we have our system. Again, this could be your game, could be your calculator, could be your calendar app, your web application, whatever it is. Here is your system boundary. Up here could be all of your requirements that are relating to data, right? So you need to process stuff in a JSON format. You need to be able to read CSV files. You need to read XML files. Whatever you have to do, you're probably going to have requirements specifying that. Okay, well, how does it link up to your system? You have some structures that hold the data. This data may then get refined into further and further and further finer grained structures of information. It's possible, depending on what you're representing here, maybe you have a transformation happening to take structure A to split it up into C and D, right? What's causing this split to happen? Or is it simply a copy operation? I mean, at this level, we don't necessarily know, but hopefully you can kind of get the idea that taking a data-driven application, I mean, maybe it's not even data-driven. I should probably stop using that term over and over again. Maybe it's just some data that you have to handle, how it gets passed along in our system here. Here's another example too for you. This is basically replicating data across a network. So we have a bunch of servers spread throughout. We have some users down here probably grabbing data from all over the world. And the finer points of this aren't really important. Kind of the key here is that at the very top level, you have some kind of a cloud storage provider, like a Google Cloud, an Amazon, or an AWS, Microsoft Azure, DigitalOcean, whoever your cloud provider is, will have servers with databases, with file stores, with, however you're hosting the data. And we're going to decompose this data into, in this case, files, right? It doesn't have to be internal structs. This could honestly be a high-level systems administration type of diagram where your data is being stored in files. Maybe it's being striped across multiple databases. Here it is in a big table, big data format. Here's how this data gets filtered out to all of our users. Right here we have a nice cloud-based application. Here we have a local, this could be an embedded systems operation where we're processing image data as it comes in. The key is that we just need to represent how data is stored and how it's shared. So hopefully the kind of the point that you're getting here is that we are making things simpler and we are looking at it from a key perspective. Yeah, so that was data. Next one, look at the processes. Now, what is a process? This is basically going to be a sequence of operations that we have to perform, right? So if we go back to the game example, update all of your enemies. What does that actually mean? Well, we're probably going to have a list of, say, 100 enemies. They might be different types, different classes, but they're all going to need to update. That could be following their AI steps, could be Doing collision detection, could be updating their location. Effectively, we have a process for some object in our system. It could be at a very high level, update the whole game. Could be at a lower level, update the enemy, update the player, update the environment. What is the process here? So what do we care about in this case? If we look at it from a high level, what are the main tasks of the system? How do we kind of decompose that into smaller and smaller processes? How do they interact with each other? Things of that nature. And low level, again, would be basically just more detail. Things you can, actually, sorry, let me pop back right here really quickly, because the one thing I wanted to talk about here too in data-oriented, so those of you that have taken like database classes in the past, data-oriented decomposition could be like an ER diagram or a database diagram. So that would basically show how data is formatted. It's kind of a good example too. Just, this view here is very programming centric, but representing how your data is modeled would be another example of this. And if you have no idea what I'm talking about, when you get to your databases classes, you're going to get an ER diagram and you'll be like, oh yeah, okay, that makes sense now. Basically, you're just structuring out how your data is laid out. Process diagrams, we're going to look at in terms of like a data flow diagram, which sounds kind of odd since we just talked about data. But basically here, we're going to have some process, and we're going to see how it interacts with other processes, with other objects, with data stores. Basically, the key here is that you're going to have some kind of a process. Usually in a data flow diagram, it's represented by a circle. It's going to be something. And what you're going to care about, what data is coming in, what data is going out, how are things being changed here. So in this example, we're processing orders for stores. Could be online, could be in person. Basically, we have some objects here. So you might have a list of accounts, might have a list of stores, a list of sales, list of customers. Basically, here we have things that are interacting with the system. The circles are going to be processes that happen. I should mention this is a formal type of diagram. Data flow diagrams are something which are quite helpful when describing a lot of systems. So if you like graphing out your programs, I would look into data flow diagrams because they can really help you see how things relate to each other. But here, in this particular model, you might have a data store or a database. So here's your customer data. Data comes into your order, data goes back to the database. Here we're verifying, we might be transmitting data. Basically here, you demonstrate how all of these individual processes relate to each other and how data is being transformed along the way. So ideally, this was going to be a, I like this model personally. Just my perspective, other people like different models, obviously. But this one kind of really shows you how things fit together. So if you were doing the video editing example here, we might have a circle for load Premiere, a circle for load video, a circle for apply or select filters, a circle for chop up video. So these would all be processes that you could follow. And your transitions between them would be, okay, now you have a chopped up video, now you have a filtered video. You're going to basically show how things all connect to each other. And it could be sequentially, could be concurrently, just depends on your program. Works for procedural, works for object-oriented, whatever you need to do. Right, so we had data, we have process-driven, feature-driven, function-driven, object-oriented driven, now we have event-driven. So this kind of plays very nicely in the object-oriented model. All of you that are programming in Android, in Apple, I assume it's still called Xcode. You're developing Apple phone applications, developing Android apps, you're developing web applications, you're probably familiar with events. So this is where a thing happens and you have to handle it. So basically it's going to be like a callback function driven application, right? Thing happens, thing being your event, you have code that handles that event. User clicks a button, what do? User taps the screen or swipes, what do? Here, basically, you have a flipping of the responsibilities, right? So you're not just procedurally coding, now you're handling events, and they could happen really at any time. Good question. Is every form of decomposition based on requirements? Seems like you can just refer back to your requirements to decompose your program. Yes, they are probably now done in Swift. It's been a while since I've tried making an iOS application. Yes, so you can refer back to your requirements for all of these. The key with all of these different perspectives is that you're looking at your program in a different way. So if you need to format your data structures, you would look at a data-driven decomposition. If you need to figure out how everything relates together, there's your process or your object-oriented decomposition. Yes, they all tie back to requirements or to any of your models, but you get a different view of how things fit together. So yes, absolutely, they refer back. And yeah, Swift is not something that I've really played with. I know that's the new thing. I guess you could make the same argument. It's not Java as much anymore now. It's going to be Android or Kotlin for Android, I think, right? Is the new hotness for that. I got really frustrated with trying to do mobile development. I basically just gave up on it, which is probably a bad thing to do. Sorry, I hear a 1-year-old jumping in his crib when he should be sleeping. Oh, should be fine for a few minutes. Alrighty, so event-driven. In this case, we are looking at the events that we have. What is going to happen? What do you have to handle? Now, when you can figure out all of these events that you have, you can assign them to the different modules, assign them to different processes, assign them to functions. It just depends on what level that you're looking at here. For instance, you look at it from a high level, what are all the input events that you have? Last time we talked about cohesion and handling user input, right? Whether it's mouse, keyboard, trackball, touch, whatever it's going to be. These would all be events that you could handle. Now, do they all go to the same input handler? No, they would go to different ones, right? A mouse click is different from a keyboard event. Keyboard event's going to be different than a multi-point gesture. So key here would be to take this event and show how it's linked up to your different processes or modules or even states. So do I have, yeah. So if you're trying to figure out how event-oriented decomposition would look, consider almost like a state diagram. So we didn't really talk about state diagrams. I said we might get into it if we had time. But basically, you're going to have a start state, then you're going to have a set of states for your system. So basically, what is it doing? How does it get to the next state? Basically, how do you kind of run through your program until you get to the end state? So I probably should explain this since we didn't talk about it. But if you have let's take a phone app, for example. You start it up. So you start right here, and then you're waiting. You're waiting for the user to do something, right? Click login, click play game, click exit app. You're waiting for an event to happen. Based on which event occurs, you would follow that particular transition to the next state. So I click the little user icon, I go to my account page. So I'm kind of just coercing this model into my own example here. So we're waiting, now we're at the user account page, not full power. So this could be basically waiting, user clicked account link, go to account page. Wait for user to do something. User clicks quit, go to the quit, the end state. Oops. So basically just try to figure out what events are happening, what that does to your program, and how that can link up with your modules. again, different perspectives. I hope I'm not losing anybody here. But what kind of the key takeaway is that we are trying to figure out how we want to look at our system. And if any of this sounds kind of wishy-washy or hand-wavy, there are formal models for each of these steps, but the key really is to understand the purpose of them. So if you're trying to figure out how data is flowing across your application, look at it from a data-driven perspective. If you're trying to figure out which classes to define, how they relate to each other, what the inheritance or relationship rules are, try to do an object-oriented type of decomposition. Okay, here's all the classes that I think I need. Let's start drawing relationships. Let's start defining attributes. Let's start defining operations. Okay, well, we have all these operations for this class. What do they do? Start looking at it from a functional perspective, right? Here is a list of functions. What are they going to be doing? Just kind of break things apart, again, into manageable pieces. So here I have a mathematical expression. So this would be in Java. I guess or it could be any language depending on your perspective. But we are trying to build up a mathematical expression. So at the very lower level, we are going to be subtracting 4 from 2. The output of that, we're going to add the 6. The output of that, we're going to multiply by -1. So here we have something that has to be done. It's going to be a mathematical expression builder. This is probably helpful for those of you building the calculator application. But the question here would be, what kind of a decomposition are we actually performing? Because here we're decomposing the idea of a mathematical expression into manageable chunks. We are decomposing in this case. What do you think this could be, based on what we've talked about today? Any guesses here? Functional. That's a good guess. Why would you say that? So that's actually a good guess that I hadn't considered, mainly because it's breaking apart the functions. Right. So I could actually see that. So I'm not going to say that's wrong because I think your logic there is correct. So my gut for this type of an expression here would be that it was more data driven because you're breaking apart the data and managing it into manageable chunks here. But you're absolutely right, it's breaking apart the functions. Sure. I don't see why not. Some of this is arguable and a lot of them have overlap. So that's one of the other aspects to decomposition too. Now, if you want to go gung-ho and start following formal models for breaking things down, it might become very clear why you'd use one or the other. You could also consider this to be object-oriented in a way too, right? Because you have different objects that are interacting, right? We have a literal object, we have a subtraction object, an addition object, multiplication object, and we're linking them together, right? So we have a atomic literal object. We have a subtraction object, which is probably expecting 2 or more literals. So you have a relationship there. You have the addition, multiplication. So yeah, I mean, yeah, you're right. Could be functional. Absolutely. Maybe these are not objects. Maybe they're just functions. So I actually like that answer. Cool. All right, so we also have decomposition in a media. Insert elderly professor / dad joke. So then I've got a slide here for you, and then we'll probably end for today. So why do we typically, well, the slide is not going to be related to this. So I'd say, why do we use object-oriented decomposition? Again, I've said this over and over again today, but just to kind of bring it back full circle. We use it to simplify our job and to make things manageable. If you don't decompose your system, you're going to have a very complicated project development process where it's very difficult to get into it. But if you break things into manageable chunks, it's easier to work on. You can more easily define relationships, define attributes and operations, things of that nature. So ideally, it helps you out to do this process. Can you use other types of decomposition in an object-oriented system? Absolutely. Right, so we talked about functional, which is kind of more of a procedural type of decomposition, right? But like was said here, it could relate in there, right? It could be related to the operations and the functions in your classes. It could be focusing on data-driven, which doesn't care if it's procedural or not. So absolutely we can use them. So question for you all, how would you apply decomposition to your term projects? Start presenting to display poll results. I am presenting, thank you. Let's try this again. Oh, I got logged out in the 10 minutes in between. Really? Fine. There we go. So think of your term projects that you've got. How could you apply decomposition to it? And I don't care what type you use. Right, so like if you wanted to do a data-driven decomposition for your term projects, what would that entail? If you wanted to do object-oriented or functional or process-based, how would that impact you? I actually want you all to think about this because this is might help you get over a stumbling block that you're currently seeing. Right? Maybe you're stuck on how do we display graphics or how do we animate something? How do we get data from a database? How could you decompose that problem? It sounds like if anybody drops by office hours, there's going to be a 1-year-old involved as well, because he is not sleeping. I don't think anybody can hear that. It's just upstairs yelling. All right, any guesses here? If not, you all get my latest update here. Could use event decomposition to determine how the user interacts with the disk. Hey, that's a good example. So you're doing the RFID tag project, I assume. The event would be that the disk comes into range or that the user is searching for the disk. That's a great example. So I think I mentioned I started refactoring my little procedural generation playground into Godot just to try things out. And I was getting really frustrated with my user input. So I figured I'd just use something like this. Hey, got another example. Functional decomposition to determine what the user wants to do with their tasks and agenda. Yeah. Yep, I could see that. So if you have a more procedural view of things, what are the steps that they would do? Or if it's object-oriented, what are the functions associated with them and what are they doing again? Yep, definitely. But kind of the key with these problems that you're seeing, right, is that you're breaking it up into manageable chunks. In these chunks, you could relate back to your requirements or your various UML diagrams to show this is why we are performing this particular operation. Right, so what the user wants to do with their tasks and agenda. You've got a requirement talking about the tasks. Here's how we manage that. You have a use case diagram for your agenda. Here's how we're doing this. Good job. We don't need to talk about my current experiments with Godot then. But, awesome. So on Wednesday, we will, guess this is good for delegating tasks. Yeah. Delegating tasks or just working together. Decomposition seems like it would make testing requirements more easy. Yes. Again, the more fine-grained of a piece of your project that you have, the easier it is to, like you said, delegate or share to test, right? Smaller things are, the more manageable it is. It's kind of the takeaway here. All right, good job. I will see you all on Wednesday. We will talk more, and we're going to be getting into test-driven development. It's going to be the bee's knees, to use a old man term. Alrighty. Bye, everybody.